Today we will now recall what we have done on Friday, that is 3rd of April. We will start with real numbers again. We will recall what are real numbers. So as we have discussed already, that real numbers basically consist of rational numbers and irrational numbers. So a set consisting of both rational and irrational is called a set of real numbers, wherein you also know that rational numbers contain all types of numbers like natural numbers, whole numbers, integers, fractions, and so on. Also, if you look at the decimal expansion of rational numbers, we say all the terminating decimals and non-terminating repeating decimals, they all form rational numbers, whereas the third type of decimals, that is non-terminating and non-repeating, they come under the category of irrational numbers. Now let us discuss irrational numbers in a little more detail, and then we'll come back to rational numbers once again. Now we were talking about irrational numbers. Now let me first make you clear the difference between square and square root, cube and cube root, which you have already studied in class 8th, but let us just recall it in case you have forgotten. So when I say square of any number, say square of 2, that means 2 raised to the power of 2. But if I say square root of 2, I will either represent it as square root of 2 with this symbol, or I can write 2 raised to the power 1 by 2. Similarly, if I write square of 3, I will write 3 raised to the power 2. Or if I write square root of 3, what will I write? The symbol square root 3 or 3 raised to the power 1 by 2. Cube of 2 will be 2 raised to the power 3, whereas cube root of 2 means this symbol. We'll write 2 under this cube root symbol, or we can write 2 raised to the power 1 by 3. Similarly, if I say fourth power of 2, fourth power of 2 will be 2 raised to the power 4. If I say fourth root of 2, what is the meaning of fourth root of 2? I will use this symbol for the fourth root, or I can say 2 raised to the power 1 by 4. So basically, square and square root are the inverse processes of each other. Similarly, cube and cube root are inverse of each other. Fourth power and fourth root are inverse of each other. Now suppose you want to find out the square root of a number, say 256. We have to check out whether it is an irrational number or not. So first of all, what we do, we will find out the prime factorization of this number, that is 256 gives us how many times 2? You can count 1, 2, 3, 4, 5, 6, 7, 8. It means I can write it as square root of 2 raised to the power 8. Now, as I told you, what does this symbol mean, square root of 2? That can also be written as raised to the power of 1 by 2. So it comes out to be 2 raised to the power 8 into 1 by 2, which gives me 2 raised to the power 4, which you all know is equal to 16. Hence, it is a rational number. Now, there is one more way of solving the same question. Suppose square root of 256 I have written as square root of 2 raised to the power 8. I can write this as square root of 2 raised to the power 2 into 2 raised to the power 2 into 2 raised to the power 2 into 2 raised to the power 2. 2 plus 2, 4 plus 2, 6 plus 2, 8. The total power is 8. So this can be written as square root of 2 square into square root of 2 square into square root of 2 square into square root of 2 square. That gives me, now because this order and this power are same, this number 2 can be taken out. Similarly, order and power are same, so this 2 can be taken out. Order and power are same, so in all of them number 2 can be taken out, and our answer comes out to be 16, which is a rational number. Now if I take the fourth root of 256, just look at the change what I am going to make here. Fourth root of 256, again prime factorization of 256 will give us 2 to the power 8. Now I will break up 2 to the power 8 as 2 to the power 4 into 2 raised to the power 4, because I am trying to match the power of the number with the order of the radical sign. This can be written as 2 raised to the power 4 into fourth root of 2 raised to the power 4, which is again 2 into 2, because order and power are same, so this number 2 can be taken out. Similarly, here the order and power are same, so this number 2 can be taken out. So the answer comes out to be 4, which is a rational number. Now let's take an example of cube root of 1024. If you do the prime factorization of 1024, you will come to know it is 2 raised to the power 10. Now I can break it up. How will I break it up? Because the order of the radical sign is 3, I will try to break up this power 10 in the groups of 3, like 2 raised to the power 3 into 2 raised to the power 3 into 2 raised to the power 3 into 2 raised to the power 1. That makes it cube root of 2 cube into 2 cube root of 2 cube, cube root of 2 cube into cube root of 2 raised to the power 1. Here order of the radical sign and the power is same, so the number is 2. This and this are same, so number 2 can come out. This and this are same, again the number 2 can come out, but because this and this are not same, so this number 2 cannot be taken out, so it will remain within the radical sign. So now the final answer is 8 into cube root of 2. That means the simplified form of the irrational number 1024 is 8 into cube root of 2. This is an irrational number, as well as the simplified form of cube root of 1024. Similarly, if I take another number, say I'll just take an example in a simplified form now. Suppose I have fourth root of 2 raised to the power 5 into 3 raised to the power 4. I can write this as fourth root of 2 raised to the power 4 into 2 raised to the power 1 into 3 raised to the power 4. I am trying to match the powers with the order of the radical sign as far as possible, so that the numbers can be taken out of the radical sign. Now this is equal to, here order of the radical sign is 4, power is also 4, so this number 2 can come out. This order and power are not same, so this 2 cannot come out. Order of the radical sign and the power of the number is same, so this 3 can come out. The only number which cannot come out is this, so it will remain within the fourth root. So it is equal to 6 into fourth root of 2, which is also an irrational number, and we can also say this is the simplified form of fourth root of 2 to the power 5 into 3 raised to the power 4. This is a simplified form of this number. Okay, now let's go back to rational numbers. As we all know, what are rational numbers? They have two types of decimal expansions. One is a terminating decimal, second is non-terminating and repeating decimal. Suppose I take a terminating decimal, say 2.5. I can easily convert this number in the form of p by q by removing the decimal and writing 10 in the denominator. That gives me 5 upon 2. which is in the form of p by q, where both p and q are integers and q is not equal to 0. Hence, we can say that the terminating decimals can be expressed in p by q form. Now let us check. Now we will see how to express non-terminating repeating decimals in p by q form. Let us, for example, take a number 2.43 bar. Its decimal expansion will be 2.434343 and so on. Name this equation as number 1. Now multiply both sides of equation number 1 by 100. Now why we are multiplying by 100? Because after the decimal, two digits are repeating themselves again and again, that is 4 and 3. So we are multiplying by 100. So we get 100x is equal to 243.4343 and so on. You know how do we multiply the decimal numbers by 100, 1000, 10,000 and so on? If you have to multiply a decimal number by 100, the decimal point will shift towards the right by 2 places. Now subtracting equation number 1 from equation number 2, we get 100x minus x is equal to 243.43 bar minus 2.43 bar. I am writing in short. So it is 99x is equal to 241. How we did the subtraction? 243.43 bar minus 2.43 bar. After decimal, all same numbers are there, so we get all zeros here, and before decimal we get 241. So 241.00 makes it 241 only. So x is equal to 241 upon 99. So this number is in the form of p by q, where denominator is not equal to 0. Hence we have expressed this non-terminating repeating decimal in p by q form, thereby showing that terminating decimals can be expressed in p by q form. Non-terminating repeating decimals can also be expressed in p by q form. Hence both these type of decimals, they represent rational numbers. Now let's see how to find rational and irrational numbers between two given numbers. Children, the assignment that we gave you on Friday, there was a question asking you how to find the number between two given numbers. So most of you were having problem with that. So let's discuss this concept first. Suppose you have been given two numbers, say 1.414. Another number is say 1.415. I want you to find out say 5 rational numbers between these two given numbers. So obviously 1.414 is smaller than 1.415. So definitely when I want to find a number between 1.414 and 1.415, that number must be greater than 1.414 and it must be smaller than 1.415. So what is the correct way of writing such numbers? First of all, look at the two numbers carefully and see 1.41. Till here, both the numbers are exactly the same. After that, there is a difference. There is a 4, there is 5. So just to increase the gap, I just put 1 0 here and 1 0 here, because after decimal, at the end of the number, you can put as many zeros as you want. It will not change the number. Okay, so now till 1.41 both the numbers are same. It means that the numbers that you are going to write in between these two numbers will also start with 1.41. All the numbers, suppose you want to write 5 numbers, so they all will start with 1.41. After that there is 40 and this is 50. So between 40 and 50 you have so many numbers, say 41, 42, 43 up to 49. So if I write here 41, 41, 42, 43, 44, 45. Is it clear that these numbers will definitely lie between these two given numbers? Because 1.41 till 1.41 both the numbers were same, so our numbers will also have 1.41. After that, between 40 and 50 we have written these numbers: 41, 42, 43, 44 and 45. So that makes sure that these numbers lie between the two given numbers. Now the question arises, if you have to find irrational numbers. If you have to find rational numbers, this is okay because they are terminating decimals. If you want to make them irrational numbers, beginning should be the same as for rational numbers. Then you can make it non-terminating, non-repeating decimals. 4141, 1, 4, 1, 1, 1, 4, then 4 times 1 and so on. Here it is 4, 2, 2, 4, 2, 2, 4, 4 times 2 and so on. This way, or if you want, you can write any digits if you want: 7, 9, 5, 6, 8, anything. 0, 1, 9, 7, 5, 6, 4 and dot dot. Don't forget to put dots after this. And so on. So this is how we find out the rational and irrational numbers between two given numbers. And remember, there are infinite rational numbers and infinite irrational numbers between any two given numbers. Now suppose I take another two numbers, say 1.718 and 1.894. Suppose these are the two numbers. Then you can easily see between these two numbers, among these two numbers, this is smaller than this. So I want to find a number which is greater than 1.718 but less than 1.894. So 1 point till 1 point both the numbers are same, so my numbers will also start with 1 point. Okay, and then 718 and 894, there are so many numbers between them. I can write 719, 720, 721, 722, 723 and so on. Once the beginning is correct, then if you want to make it rational, leave it as it is. If you want to make it irrational, just keep on adding any digits after this and make it non-terminating and non-repeating, and don't forget to put the dots in the end. So this is how we find out rational and irrational numbers between two given numbers. Let us find out rational numbers between 3 by 7 and 4 by 7. As you can see, the denominator of both the numbers are same, and this is smaller than this number. So we need to find out a number which is greater than 3 by 7 but smaller than 4 by 7. Just to increase the gap between 3 and 4, can I write 3 by 7 as 30 by 70 and 4 by 7 as 40 by 70? So now I need to find out the numbers between 30 by 70 and 40 by 70. So I can write the numbers 31 by 70, 32 by 70, 33 by 70 and so on up to 39 by 70. If I further want to increase the gap and want to write more numbers between these two given numbers, I can increase the gap by writing 3 by 7 as 300 by 700 and 4 by 7 as 400 by 700. So now there is so much of gap between 300 and 400. We can write so many numbers like 301 upon 700, 302 upon 700 up to 399 upon 700. So this way you can introduce as many numbers as you want between two given rational numbers. In this case, the denominators were same, both of them were 7. Let's see a number where the denominators are not same, say 3 by 5 and 2 by 3. So first of all, we need to make their denominator same by taking the LCM, 15. Then I'll get 9 here and 10 here. So now I have to find out the numbers between 9 by 15 and 10 by 15. Now the denominators are same, so the numbers that we are going to write will also have the same denominators, but the numbers should lie between 9 and 10, the numerator. But between 9 and 10 again we don't have more natural numbers. So just to increase the gap, we just write 0 in the numerator and denominator of both the numbers. Now the gap is increased between 90 and 100. We can write so many numbers: 91 upon 150, 92 upon 150, and so on up to, you can say, 99 upon 150. Further, if you want to increase the gap, you can make it 900 upon 1500 and 1000 upon 1500. So now the gap is again increased from 900 to 1000. I can write so many numbers: 901 upon 1500, 902 upon 1500, up to so on, say up to 999 upon 1500. So this is how we find out rational numbers between two given rational numbers. Now coming to number pi, you must have heard about the number pi in classes. I think in class 8 you must have used this number for calculations. The value of pi that we use is either 22 by 7 or 3.14. Now looking at the value of pi, if I ask you what type of number is pi, is it a rational number or an irrational number? Immediately your answer will be it's a rational number, because we have written it in the form of p by q, 22 by 7 or 3.14. But remember children, pi is not a rational number, it is an irrational number. Now why it is an irrational number? Because the actual value of pi is not 22 by 7 or 3.14. The actual value of pi is a non-terminating and non-repeating decimal. That is why it is an irrational number. Now 22 by 7 or 3.14 is only used for calculation purposes. It is only an approximate value of pi and not the actual value of pi. So there should not be any confusion regarding pi. Yes, we use the value 22 by 7 or 3.14, but this is only an approximate value of pi which we use for calculation purpose. The actual value of pi is a non-terminating and non-repeating decimal. That is why pi is known as an irrational number.